Hi everyone, in this video I will show you the output and the waveform from a Variac, and we are going to observe that one in this little guy, this oscilloscope here. Now before I go on further, I will say that this experiment or this test involves 110 volts. In some areas it's 220. So don't do this one, because if you get in contact with a wire you might get severely injured and it's not good. So if I would suggest talk to a professional or licensed electrician or somebody who knows how to deal with these things. Okay, so if you don't know anything, I suggest just stop the video and talk to a professional. All right, so let's get started. So like I said, I have an oscilloscope here. I have the Variac, and right now I have a differential probe here. So you cannot connect the oscilloscope directly to the output of this Variac, because it will damage your oscilloscope. All right, so you want some isolation between the oscilloscope and the Variac. So this is what's inside the Variac. So you have 120 volts AC, and this is the ground, this is the voltage output, and there is no isolation here. So you cannot, like I said, you cannot connect the oscilloscope directly. So I have this device. This is a differential probe. All right, so it creates an isolation, and also it handles higher voltage, because oscilloscope they can handle lower voltages. If it goes beyond the limit, it will cause a damage. Okay, and also the differential probe is connected to this wire here. So there's a white, black and green. The green is the ground, the black is the hot wire, and the white one is the neutral. Okay, so that's how I connect this. Let me fix this guy here. All right, make sure it's clipped properly and not in contact with the other wires. Okay. All right, so let's turn on. So by the way, I set up the differential probe to times 200. Okay, so it attenuates the voltage down to 200, divided by 200. And I set up the oscilloscope to times 100. So the result, that whatever you read in here, you just times 2. Okay, so attenuate 200 on the differential probe and times 100 on the oscilloscope. There's no 2 times 200 on the oscilloscope, so I just pick up the closest one. All right, so anyway, let's get started. Let me turn on this one. Okay, and there are readings here. So you have the voltage peak to peak, the V average, frequency, VRMS. We are interested with the VRMS. So whatever you read there, you just times 2. Okay, because attenuate 200 on the differential probe and times 100 on the oscilloscope. So you just times 2 it, whatever reading we get here. So let's start rotating this guy. Okay, so you can see the waveform is moving up, and let's see, you can see the voltage here. This is typically that what you're going to read on the voltmeter. Okay, so right now it says here 17.9 volts, so times 2, it's around 30, 34, 35. So let's go up all the way, and you can see it is a sinusoidal waveform coming up from the power source or electric company. Okay, so now the VRMS is 61 times 2. It's about 24 volts, and we can go up further. So this output can go higher than the voltage from the power company. So right now it's 71 point, well, let's say just 70 volts VRMS times 2 is 140 volts. So it is higher than the power coming from the company. So this can also like go higher than the higher voltage. So it's like a step-up transformer. Okay, so this is it. So planning to get one of this for your experiment if you're advanced hobbyist who knows about electricity, or as long as you know what you're doing. Okay, it's so at your own risk. But this is it. This is how you use the also use the oscilloscope to read the output voltage from the Variac or variable transformer, and then you don't connect the oscilloscope directly to the power source because there's no isolation and it can damage your oscilloscope and even cause problems, injuries, those kind of things. Okay, so let's turn it off and that thing should go down. Okay, so anyway, thanks for watching. If this video kind of informative, give a thumbs up, and hopefully I'll see you guys on the next video. You guys take care. Bye now.